Hi everyone, and welcome to this session where we're going to be talking about decoupling your legacy on-premise systems, your Oracle, SQL, SAP, mainframe, and the like, and enabling real-time data into the Lakehouse. My name is Ted Orme. I head up data integration strategy here at Qlik, and I'm joined by my colleague Jordan. Hi, Jordan.
Hey, Ted. Good to see you and a lot of old friends.
So what we're going to cover today, I'm going to do a few slides at the beginning, just talking around the industry as a whole, Qlik, the journey that we've been going on, before Jordan's going to do a deep dive into the technology and show a live demo, and we're going to have some time for Q&A at the end. But first, just a legal disclaimer. So we're Qlik. We're a software company. We've been around for a very long time now, helping organizations run analytics. We're a market leader with our analytics and visualization tools. That's really what you may know us best for. Really what has changed is through acquisition, we now take a holistic view of an end-to-end journey of data. I come from the Attunity side of the business, now rebranded as being Qlik Data Integration. And really, what are the challenges that we're helping organizations on? We're helping organizations truly understand their data better, get the value out of their data, the business value. And the challenges we see is that organizations often don't really have access to the right data. They don't all maybe trust the data that they have, or they don't have the tools or the skills in order to get the value out of the data. So how are we helping organizations? We're helping organizations really turn that data into business value with three core business components from Qlik: data integration, data analytics, and then data literacy as a service, being able to have a conversation and actually then argue with the data. How do we do this in the flow? We really, by overcoming those challenges, closing the gaps, and then where the integration layer, that's where the Qlik data integration is streaming real-time data out of operational systems, bringing that data to the business, bringing the right data in the right formats to the business, where the business can then drive action and insight out of that because they have the skills and the tools associated. So these three pillars are the flow that we can help organizations get the value out of the data. So freeing the data, finding it, running the analytics against that, and then having that conversation with the data. So what we're going to do, we're going to look in a little bit more detail now around Qlik data integration, and specifically around what we call digital decoupling. What does that mean? What does that mean? It's really digital decoupling is where you're building out applications, building out other systems in order to better leverage the core legacy platforms that you have today. Legacy platforms, which ultimately are there to run your business, sell more widgets, sell more policies, drive more revenue out of the organization. But CDC is the key component for change data capture that streams data out of those systems into those secondary, into real time, into the Lakehouse. So we see three types of organizations and how that they're using their legacy platforms. What we call here the laggards, really, but this is really what people used to do, in that they have their core systems and they'd build more applications on that, but you'd have a lot of cost associated with that, as you're building more applications directly on your source systems. So the first stage of decoupling was using sort of ETL tools to output to a warehouse lake environment, but they're seen as being batch orientated and quite separate from the core legacy systems. What we're really seeing is the innovators are the ones that are using real-time data, streaming real-time data out of their Oracle, their SQL, SAP, mainframes and others into a unified cloud elastic structure, and then running the transformations there. This then actually brings the data closer, brings the business closer to those legacy platforms. And by the business coming closer to those legacy platforms, that is really then driving innovation and change, where they can actually use the data better. And real time is the key for that, because real time then brings that data to the business so that they can drive innovation and change. We look at the benefits that these three environments have. Typically the costs, if you're just building more applications on your legacy platforms, you'll start getting a bit of benefit. But over time, the complexity, the business value will decline, because they're difficult to maintain. You've got to maintain all of those applications that are running directly against the mainframe or against the on-premise environments. So the early adopters, they exposed the data, they got the data into the cloud environments faster, and they got to see some value out of that. But it was still only batch. It was still only, it was then still complex. is actually the true decoupled environments, the true innovators can then stream real-time data into their cloud environments, and then they can start building applications that are driving business value. And this is really where I love the quote that the CDO of MasterCard said a few years ago now, it's not the big fish eating the small fish, the fast fish eating the slow fish. You can do better things faster with your data. You'll see the benefits and environments and be more competitive in the market. So now we're just going to quickly look at 3 trends we see in the industry about why. What I mean by here is why are organizations going through this journey? And the first one is around that application modernization. And here it's everyone knows it's this, isn't it? It's the mobile phone. Everybody has the mobile phone with banking applications on there, and you need real-time data for that. The open banking platforms that are being built now are streaming. You need real-time data, streaming real-time data out of mainframes, out of Oracle, those billing systems into the cloud and building out applications. Really, that's been one of those the real big drivers. The second trend that we've seen is around the modern data warehousing platforms. Whether or not this is Redshift, this is Synapse, this is Snowflake and the like, the drive, but the warehouse environments were also sort of complex, meaning that those cloud data warehouses are driving innovation and change, but you don't want to just reuse your traditional ETL platforms. If you're going to reuse ETL, there wasn't any benefit with going to the cloud, where those cloud warehouse environments. And here, this is where we offer automation. We're streaming real-time data and then automating the value out of the data that you're delivering. The data is being streamed and delivered and then made available to the business in a usable format. And then that third trend is around the modern cloud data lake. But actually, these are the lessons learned of the sort of the first generation of Hadoop and on-premise environments. But actually, cloud-based environments in elasticity, and here this is the world of Databricks and the cloud, in order to really truly use the data better. So these 3 trends: application modernization, data warehouse modernization, and the next generation of data lakes all come together. What we used to see in the past is business used to come to IT and say, can I have this SAP data? And IT would go to an ETL vendor and move that data and create just another silo of data. Line of business would then have this line from source to target for that individual line of business. And then the next line of business would come and ask for data, and the next and the next. But what we now see is the overall, all of these applications, all of these use cases coming together in this cloud-based environment for the Lakehouse, on any cloud, on multiple clouds. This is where Qlik Data Integration are seen as being the leading independent vendor for data integration, streaming out your most valuable data. You know what is your most valuable data, the transactional systems, the Oracle, the SQL, the SAP, stream that directly into any cloud environment, and then run the analytics at the end of that. This is the journey that Qlik are helping organizations on, having best of breed solutions, both for integration, analytics, and being independent of wherever the data lives today and whatever type of data. So our uniqueness about bringing out the mainframe and SAP, we'll look at a little more detail in the demos and environments here about what the data is and how we do that. We can deliver that data in a usable format to the business, whatever platform you're building today, and then run the analytics against that. And that really is how Qlik are helping organizations, really showing the value of that end-to-end, that are changing the way in people think about this, as opposed to not just an IT challenge, not just a business challenge, but overall, how best are you using data and enabling you to have better access to that data. So now we're going to have a look in a little bit more detail and look at some of the underlying products technologies, and I'll hand over to Jordan to do a deep dive into the products.
Perfect, Ted. Thank you. So what we're here to talk about today is how Qlik and Databricks have a deep integration. And when you think about the data challenges that Ted noted, what we're looking at are a couple of different scenarios, right? The ingestion, the storing of the sequencing of the data, how you manage that, where Delta really shines, the management, the governance, the integrity type of sequencing that you would consider, and then the consumption layers, right? Our QDA analytics platform. When we look at our approach itself to a lakehouse and how we take agile data operations and being able to consume, whether they're the incrementally loaded in batch scenarios that load into Delta files, and then they may have CDC integrated into them, and they should, when you're looking at the raw deltas, trying to consume them and bring them back together into a arena of like the table being a full history, evolved and merged in ELT, and then managed to handle for schema evolution history. And that history may have certain considerations. We describe them as operational data stores or historical data stores. That's where you see right here. And what that covers is the type 2 history, the actual snapshots that allow you then to fully understand the life cycle of that data set. When we look at this at our Databricks platform, when we're taking in all of our sources and we're loading from that same system, we're going to load today into Delta. That's what I'm going to demo. We're going to load into the Delta actual Spark operations and into the Delta tables, updating the metadata, the underlying file system from one of the 3 clouds. And as well, when we do this, we're all about sequencing it and enabling it so that you can take over with notebooks and do a ton of powerful machine learning, scoring, and consumption of BI for that lakehouse. If we want to, we integrate to our, if needed, we integrate to the system via our catalog. It hooks in via JDBC to different systems. And that also helps you to understand the full lineage of those tools. When we talk about CDC, this is our staple of our platform. When we talk about that replicate product, there are a couple of key sequences that are involved that make it unique. There's the handling for schemas and data types. It will enumerate a list on the source to a list of corresponding target data types on that target. It has that very parallelized and optimized full bulk load. But at the bottom, where you really talk about the transformations and the filters and the ability to handle for changes in DDL, that's really where the sequencing takes off. When the sequencing takes off, what we're able to do is transform and change with the data. That time stamping and that leverage of what happened at the source and the ability to replay that evolves the current data architectures that we're used to. We, as Ted noted when we talked about the Hadoop markets, now the Delta Lake, and now even to the Lakehouse, that overall sequencing is incredible for that transformation. What we're going to look at are what are these next generation lakehouses, right? That acceleration to cloud, getting rid of components in the data warehouse for the object store and processing it using Delta, and then merging those data architectures into that lakehouse that we noted. We're going to talk about a customer, JB Hunt. Joe was one of the ones that helped us through this journey. And in this example, what they were looking for was their mainframe migration. They were talking about how they were going to load it previously and incrementally a daily load to a staged system that took, once a day loaded data, 30 minutes to refresh even the BI reports. And what that included was a lot of time doing bolt-on reporting, manual processes, and configuring the systems for change consistently. Overall, their scenario was changing their EDI, their formats for how they collected the information, their machine learning models, how they managed them overall. But really, from a business standpoint, it was the assets. They're a trucking company, and the telemetry of those assets across the ecosystem of whether geospatial applications or just the applications that run their business and the analytics within. There's so much more to that journey. Their overall journey, when you look at it, takes them into this pathway: a flexible ingestion pattern that's maintained within their Delta Lake, including mainframe, SQL, and the rest, a repository, whether they're hitting their event hubs or going directly into ADLS and Blob Store or their object store that they were using. And they have their automation, efficient replication, and the monitoring they use, like the ML ops that they use with MLflow. When you look at this, let's take it to an architectural diagram. Their current platform, enriched data pulled from DB2 using Replicate, SQL servers replicated using ADF. So a collaborative platform of multiple ETL and streaming tools, all loading to an actual Delta Lake and a lake house. As they went through their bronze, silver, gold, they had a merging of a data warehouse, they had a model training experience, they had containers serving that, a very rich and powerful experience across a multitude of tools. So Ted, I just wanted to say thanks for joining us. I'm going to hop right into the demo. So,
Sure. And then one of the things I would just like on that, this really is that modern architecture that we see in the rather having one use case, having one use case, bringing the data in to the lake house and then bringing best data out of that. That's your golden source that sits there that then services the business in a trusted format. And this really shines that whatever industry you're in, whatever environment, whatever vertical you're in, this is still the right architecture to meet that business case for each individual line of business coming to try and to get access to the data.
Perfect. So this demo, what we're going to do is, and I'll go into it in a much deeper fashion next, but covering the CDC, the batch, covering how DDL changes occur, and we're going from bronze to silver. So here's this merging functionality. We're going to generate that. All right. Well, thank you for your today, Ted. Going to the demo.
In this sequence, what we're going to discuss are the change data capture components that Replicate provides, thinking about the batch, initial load, the change data capture, and the change of the DDL. When you're going to store this, you want to be able to automatically merge into Delta, transform that Delta, and create a real-time operational data store. That data store can then be used within a Databricks notebook to build Spark ML and MLflow integrations, where we then can render them back through Qlik Sense. What this product does is it takes in the ingestion, whether it's a real-time stream or the bulk load, but it takes it into the bronze layer of Delta tables, both notifying the actual files, the tables, and the metadata associated DBFS, and as well merging into that component. In this section, we're going to be talking about how to create a connection to Databricks. We're going to be loading into ADLS, and we're also be hooking into the Metastore. As we configure that operation, we're going to then work within the Replicate console, as you can see here. The Replicate console will start with a new task, which we'll call Spark Summit EMEA. I'm going to incorporate some of the store changes functionality to carry all the histories of the transactions that have occurred prior. In that operation, we're going to configure some of the endpoints, such as this SQL Server. We can connect to a bunch of different platforms, whether they're on-prem or in the cloud. And we're then going to target the Delta component from our Replicate console and connect to it. So we bring over our two sources and targets, and what we're going to do is we're going to tune that both for the full load and optimize the loading functionality, as well as then the number of tables that we're going to pull from, some of them being smaller, so we're just going to extract them very quickly. I'm also going to incorporate some of the store changes functionality, which which is aware of the partitioning requirements on the system. As you bring these data sources over, now we're selecting multiple schemas and multiple sets of data. I can also adjust my columns as I need to, so such as maybe do some math functions, add first name, last name, or put in date times and impute some null records as you're going. What I'm going to do now is we're going to kick this off to do some bulk loading via Replicate. As we're loading these records, we're going to be loading about 7.8 million records in this operation. Let's get this started. We're going to click this Start Processing, which begins creating a loop of all the tables, 74 tables. We've loaded that into what we call the perf bronze schema that's inside Delta. And what we're going to do is we're going to bulk load all of these over. As you can see on the screen, there's quite a few of the smaller ones in the thousands and a couple hundred records in each table, often lookup tables or dimension tables in the data warehouse. But as we're loading these operations, what you're going to see is we're going to start to hit in the millions of records, such as the fact and sales information records. What you see right here, you've got sales order enlarged with about 4.8 million, another one on order header, which is about 2.2 million. And these bulk loads are really bringing over a lot of records. And you're seeing 2,000 records a second, and it's moving across. As we process this operation, most of the data comes over in a compressed format. Those are the two components of a Replicate task. There's the integration to the source database and how it's part of the native database. And then there's also the in-memory task of transferring the data in a compressed and an encrypted format. Some of this data, as it's almost completely finished now, will be both mapped for common data types between two systems, as well as then the handling of the batch and the generation of the types of code native to bulk copy, often like the BC bulk copy command. And as we're almost done with this one, I think this is sales order header, and it completes, we're going to discuss creating a replication task. Now that we've got all that over, and that lasted all of about 5 minutes, we're going to go into part 3, which talks about capturing, merging, and managing those real-time changes. As we capture and manage these, what we're going to be looking at is the deletion of millions of records that you can see right here. Secondarily, we're also going to run a bunch of inserts. I think like at one of the tables I put 1 million, another one 100,000. And in this utility, we're going to kick off and manage both multiple tables that are listening for inserts, updates, and deletes, CRUD operations. When it's running these operations, what Replicate does is it becomes a native deployment of the source system. For instance, we're hooking into a SQL Server, so it's using its own inherent ability to understand the SQL engine. None of the replication APIs, but a very core integration to the SQL Server engine. They have like binary log reader, which is one of the key components of reading the Oracle database, or certain messages inside of a mainframe. But this listening component then gives you that really powerful extractor. And when we're generating a bunch of the code and extraction components, you're seeing millions of rows of truncation. It already captured what was in memory, so now it's cached the change records into disk so that it's read them out of the database and put them into the transfer cache of the replicate engine with the command criteria that it will then generate when it loads into the target delta. What we're looking at now is the optimizations. Like you can see that the cluster's moving along really, really well. And I'm going to go into the database and I'm going to run a count. And I've got 4.8 million records in there. Or I go to the address and I can show that we've collected sample data from those records. Thanks everybody for joining us. We'd love to hear your stories on how you're doing your digital transformation and decoupling your data.